In today's industry, cloud computing is the buzzword. It offers a wide range of services to address issues that arises frequently in management information technology and businesses. AWS Web Services is a cloud computing platform that seeks to deliver ready-to-use solution to these issues. As a result, AWS offers a set of services known as AWS Compute that helps businesses meet their computing requirements. Let's understand what the domain entails and some of the services that comes with it. So without any further ado, let's get started right away. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
So when you talk about this domain, it is AWS computation service, right? Or compute services rather. So when you talk about these compute services, it has quite a few compute services that AWS has to offer to you, or AWS has quite a few compute services it would like to offer to you. One of those, or the first ones that you see on the screen, is Amazon Elastic Beanstalk. So Amazon Elastic Beanstalk is one of those services which actually lets you go ahead and have or use PaaS offerings that AWS has to offer to you. Okay. So when I say PaaS offerings, here basically a complete platform is made available to you, which you can access, which you can use using AWS. Say for example, I have an application that is up and ready for me. I just need to move my code to AWS and start working on it, right? Let's assume that that application is built in Python. So in this case, what I would do is I can actually go ahead and launch an instance. So instead of launching an instance and setting it up, launching a virtual machine and setting it up, configuring it totally. Okay. What I can do with Elastic Beanstalk is I can actually just go ahead and fire up one of the environments that Elastic Beanstalk has to offer to me. And here the environment is ready made for me. All I have to do is put my code and my application will start working for me. The other approach, what it also does is it gives me an environment where I can actually start coding as well. Let's assume that I'm good with Python and I know how to build an application in Python. So it will actually go ahead and create a virtual machine for me. It would create an environment on top of it, and I can actually just go ahead and fire up that environment and just start writing my Python code. And my application would be up and ready for deployment. It also lets you deploy your application with a lot more ease, gives you complete status in what stage is your application and what stage of deployment it is in exactly. And using that, I can actually go ahead and deploy my AWS Elastic Beanstalk application. So we've already discussed what platform as a services are. So you can see on the screen on the left hand side, there's a small image that tells you it's a PaaS offering. That means my vendor takes care of everything right from networking to runtime. Whether it's my middleware, operating system, virtualization, servers and storage, everything is managed by my vendor. All I manage is the application or the data that I have to control. And if I were to define this service, I would say it is a compute service which gives me PaaS offerings, right? Now, unlike EC2, something that we'll be discussing next, you do not have to set up underlying infrastructure, and instead you can actually just go ahead and quickly deploy these applications to AWS Cloud Platform and manage them. So basically it is nothing but a PaaS offering that AWS has to offer to you. So I believe Elastic Beanstalk is clear to you people. Let us go ahead and talk about the other service or the other domain. So the next service that we have here is Amazon Lambda. Now when you talk about Amazon Lambda, it is a serverless compute service that Amazon Web Services has to offer to us. Now when I say a serverless compute service, what it does is it basically takes load off the developers to a very great extent when you talk about configuring part, right? Here you do not have to worry about resources. You do not have to worry about how to launch them or how to manage them. Whole management part and even the configuration part that we talked about in the past thing, it is taken care by a Lambda service. It basically actually goes ahead and works with CloudFormation. We'll discuss that. Do not worry about it. CloudFormation to ensure that most of these tasks are automated. Once you have your application, your data, you just put it here and it starts working for you. You do not have to worry about the management part as well. In simple words, you do not have to worry about the server, underlying server. Everything is taken care here by your cloud platform. So that is what your Lambda service does for you. So all you have to do is you just have to go ahead and put your code on the Amazon Lambda and it should work for you. As simple as that. We'll explore this a little more once we get into the demo. But this is what the gist of AWS Lambda service is. Okay. Let us go ahead and talk about the other services that AWS has to offer to us. So one of them is your elastic load balancers. Now, when you talk about elastic load balancers, consider this scenario, right? I've mentioned about cloud platforms. There could be a situation where your application experiences a spike in traffic. Now, since there's a spike in traffic, there could be a situation that your servers are overloaded and they're not functioning well. In some cases, your application might even crash for some unknown reason as well. Or say, for example, you have a virtual machine with you and even that crashes where all your data resides. So what do you do in this situation? When you talk about elastic load balancers, as the name suggests, these services ensure that you can balance your load on different resources. Let's try and understand this point a little more. So guys, there's a lot of theory that I've been talking about. Do not worry. Let me explain these concepts. I'll recap some of these for you and we'll take a look at the demonstrations of some of these services as well. So when you talk about an elastic load balancer, okay, what this service does is it distributes your incoming traffic across several targets. Okay, so everywhere you've been reading this term Amazon EC2 instances, this is something I'm afraid we should have discussed first. To give you a general idea, when you talk about an EC2 instance, these are your virtual machines that AWS lets you configure. You can actually plan what storage, what network it falls under. And on top of these virtual machines, these can be your Windows, Linux, and all these kind of virtual machines, right? So most of your applications would be residing on your EC2 compute instances. Okay. So that is why we see this term everywhere, like Amazon EC2 instance. We'll be talking about that in detail, but to give you a gist, this is what it is. So when you talk about elastic load balancers, what it does is it distributes your traffic. Okay. So in your case, you could have multiple EC2 instances with you. Okay. So it diverts your traffic to those instances which are idle or have lesser traffic. Say, for example, your one EC2 instance is experiencing a lot of traffic. So instead of diverting all your traffic there, it will divert your traffic to some other instance. For that, it uses AWS Lambda function. Okay. So Lambda function, as I mentioned, it manages this load. It helps you transfer this load. And then there are containers, something that we'll discuss again later. So let's not focus on the word containers for now. But in simple words, what your load balancer service does is it calculates what are the EC2 instances that are functioning in those regions and distributes your load evenly so that none of your instance faces too much traffic and crashes down. Okay. What it does is, these are some of the features that you see on the screen. It lets you automatically scale to meet the incoming traffic that you have. Okay. That is something that we've discussed already. It improves your overall performance of applications. That is obvious to happen. Let's assume that there is so much traffic on one of your instance that it is not able to handle that traffic, right? DDoS attack is something that you might have heard of, where people just throw in multiple requests on a particular application so that it crashes. But if this happens when you talk about your AWS instances, it would get redirected to other instances and whoever planned that DDoS attack, that person might fail. Okay. And this also means that your application performs better, right? Because traffic is getting distributed. Increases availability and fault tolerance. Yes, your instances are not crashing. That means they are available. And if one of the instances is facing problems, others are available for it. Regular health checks to send only healthy targets. So this falls under management as well. Your Lambda and some of your management services, what they also do is they keep health checks to ensure that all the instances in a region are healthy or in your application, basically, network basically. So if an instance is not healthy, the traffic won't be diverted to that instance. So that is what load balancer does, guys. As the name suggests, it balances the load of your resources for you. Okay. Let us go ahead and take a look at some other pointers. Okay. Let's talk about what are the types of elastic load balancers that you have with you. You have your classic load balancer, network load balancer, and your application load balancer. So when you talk about your load balancers. Your classic load balancer is the typical EC2 load balancer that we've discussed, right? So what it does is it basically understands that one of the instances facing more traffic and it diverts them to other instances. But when you talk about your network load balancers or application load balancers, now these function little differently. These operate in your network layer of your application basically, or when you talk about computer networking, we have different layers, right, which fall under your network, where basically your resources reside or your data resides, right? So when you talk about load balancers that operate in the network layer, we call them as your network load balancers, and the one that fall under your application layer are called as your application load balancers. Now this is something that we should not get into the details of, but these are some of the types that AWS has to offer to you. So the next point that we have on our screen is auto-scaling. So when you talk about auto-scaling in particular, what Amazon does is it gives you the freedom of upscaling and downscaling your instances. Okay. So let's assume that you have certain instances where your data is residing. So in this case, what happens is there could be a situation that I've already mentioned, that some of your instances might experience a lot of traffic. In some cases, they might just not experience traffic. So you can actually ensure that your EC2 instances are always available to handle a particular set of load. In case if you assume that, or you know that the load of your particular instance is going to increase, in that case, you can always set them up for auto scaling. When the traffic increases, they scale up to ensure that the functioning is smooth and in place. Okay. And you can even actually go ahead and terminate some of the instances right away. Let's assume that your instance is not expecting any traffic and it is not expecting or not having any traffic at all. In that case, paying money for that instance does not make a lot of sense, right? In that case, you can actually go ahead and terminate that particular piece or set of instance so that you do not shed any extra money on that instance. What are the features that Amazon Autoscaling offers to you? It offers better fault tolerance. It is highly available and gives you better cost management. So I do not see a point where we talk about these pointers a lot more, because it's pretty evident from the definition itself what it is. Let us go ahead and try to understand something else here. Okay, so this is one of the most important bits that we would be talking about in the compute services domain. Okay, so we've heard about EC2, something that I should have discussed prior to all the services that I discussed. But it does not matter. We'll cover this now, and probably all that we discussed will still make sense to you. Okay. So this is one of the most important services that AWS Compute has to offer to you. It is one of the most popular services when you talk about computation domains on cloud platforms. Okay. So it is one of those services that was started in 2004. Okay. I believe this was basically found by Christopher Brown, if I'm not wrong, in 2004. He was based in Cape Town. I'm not sure whether it is the same service or some other service that he found, but it was one of those first services. It was found in 2004, and it soon became one of the most beloved services in the world. And these days, EC2 provides you with so many options. Let's try and understand what EC2 service is. So guys, when you talk about Amazon Elastic Compute Cloud or Amazon EC2, it is a web service that provides secure, resizable compute capacity in the cloud. It is designed to make web scale cloud computing easier for developers. Okay. So as the definition suggests, it lets you launch instances or virtual machines, to be frank. Now these instances are scalable in nature. They're highly cost efficient and flexible as well. As we talk about the families of EC2 that we have on our plate, you'll understand these terms to a greater or a better extent. Do not worry about it. I'll explain all these points to you in detail. But this is what the definition has to say. But I've mentioned the term instances here, right? Let's try and understand what an instance is. So when you talk about an instance is a virtual server for running applications on Amazon EC2. Okay. So guys, let me give you an example here. So when you talk about building a particular application, right? What we do is, let's assume that you are given some project that you're supposed to make on your computer. Now you do not have a computer or a resource that lets you build that. In that case, what you would actually do is you would actually go ahead and buy that resource, but that would be a costlier affair for you. To give you an example, if you have to buy a laptop in India, it costs you around 40,000 rupees for a good laptop, right? With decent specs and good functioning. But what if my work was only for 10 days? Spending like 40,000 rupees for that laptop won't make a lot of sense, right? So instead, what if I could rent a laptop for say 400 rupees a day? So in 10 days, it would cost me like 4,000, right? So that is like 1/10 of the cost that I would otherwise invest, right? So when you talk about application development, it always won't make sense for you to actually go ahead and buy everything, right? To give you another example, let's assume that I have one laptop with me, okay? And in that, I need to run a project that I'm working on that works on Windows operating system. And I have another project that I'm working on that works on some other operating system, say Linux or Ubuntu. So instead of actually going ahead and having two operating systems, which is a difficult task, right? In my system, I'll have to boot it up, set up two operating systems, and the performance would be compromised as well, right? With cloud computing, what you can do is you can actually go ahead and launch such operating systems or virtual machines. And you can launch plenty of those. What that does is that gives you a freedom of working on a different virtual machine. So what a virtual machine is, it creates a virtual replica of an operating system for you. So since it is based on a server, you can launch multiple virtual machines on your laptop and your laptop won't hang. You won't have configuration or RAM issues, right? So that is what a virtual machine is. Think of it as a small computer which has its own network, its own storage, and its own capacities. So that is what EC2 does. It lets you launch these different kind of instances, these different kinds of virtual machines. Let us just go ahead and talk about what we have next. So there are quite a few families that EC2 offers to you. When you talk about EC2 now, there's so many types of instances, so many pricing models it follows, and so many things. So we'll be discussing these points in a lot more detail. So stay tuned. And what I would also suggest is some of these pointers you'll have to revisit as well, because I would be talking about a lot of information here. And once we do that, we'll get into the demo part. So guys, let us go ahead and now understand the different types of instances that AWS has to offer to us. So when you talk about an AWS EC2 instance, to be honest, there are quite a few types of instances that are available. I mean, you can classify them based on their pricing, right? Upon the way they function and upon their applications as well. Okay. So I'm not going to complicate the process for you. Let us talk about these things one by one and try to simplify the whole process as much as we can. Okay. So let's quickly get started. So when you talk about the types of instances, these are some of the families of instances that AWS offers. One is your general purpose instance, right? So when you say a general purpose instance, these are those instances that are used for general purpose applications. They would be giving you a certain amount of throughput or performance. Okay. So let's assume that you have an instance that works at n capacity. Okay. N is the total amount of capacity it has. But when you talk about a general purpose instance, it reserves its capacity. Okay. So these are also called as burstable instances. Let me throw in some light on this topic. Okay. So when you talk about a general purpose instance, let's assume it is working at a particular capacity. Okay. So in this case, it would not work at an n capacity. Instead, it would work at n minus 80 or n minus 30 capacity. That means 30% or 20% of its capacity it will work at. Okay. So if there is a requirement where you need to have a bigger or a better performance, in that case, it will burst out of its shell of 30 or 20% performance and it will perform better. With AWS, you get certain credits that are assigned for burstable performance. So you can use burstable performance for those credits. Okay. So that is what a general purpose instance is. Do not worry, we'll be launching an instance or two where we'll talk about these pointers. Next is your compute instance. Now these are those instances where you need heavy computation, right? So basically when you're talking about high compute power, that is where your computation instances come into picture. Memory instances. Now these are the instances that talk about processing data in memory. We are talking about our RAM, ROM, all those kind of features here. GPU instances that you see on the screen, these are used for graphical processing. Okay. So when you're talking about video rendering, modeling, other applications that related to graphical processing, those are the things that work well on your GPU instances. Storage instances, as the name suggests, these are the instances that give you better storage capacity. Okay. So these are the types of instances based on their families. So these are their families, that is general, compute, memory, storage, and GPU. Okay. EC2 pricing model. Now there are instances that are classified on their pricing model as well, right? So when you say an on-demand instance, it is that instance that is available on demand. It is available anytime you want it, but it comes at a higher price. It's just like renting a hotel room, right? You visit to a new city and you rent a hotel room. So there what you do is you get whatever, you go there, you'll just demand something, you'll pick a hotel room, whatever you want, and you'll take that, right? So this could be costlier. Why? Because you're doing it on the spot. Not on the spot, but on demand, right? Next is your dedicated instance. So dedicated instance is an instance that is dedicated for a particular kind of application. Okay. So you are a user and you say that I have a particular set of applications that I need to run, and I want this instance that is available only for my requirements. In that case, you go for a dedicated instance. Reserved instance, it's just like reserving your hotel in advance, right? You know, you're visiting maybe Goa or maybe Maldives or something like that, right? So you know you're going there for 4 days, and these are the days that you're going to visit there. So you reserve those hotels in advance. So you get those at a cheaper price. So same is with reserved instances. You know that you're going to need these many instances for this duration. So you'll book them in advance. Okay. So they come to you at a cheaper price. Why? Because you're reserving them in advance and for a longer duration. On spot. Now this is like bidding on something, where let's assume that you have an activity that needs to be done. You do not have any specific requirement here. Any kind of instance will work for you. This is where on-spot instance comes into picture. You just go there and you look for an on-spot instance. It is little different from on-demand instance. When you talk about an on-spot instance, it is you use what you get. Okay. So the pricing here is not fixed. There is a bidding on these instance. If you match that bid, you'll be given that instance at that bidding price. Once you release that instance, there could be a possibility that you might not get that instance at the same price. Okay. So these are the types of instances that we have from a pricing perspective. So let us now go ahead and understand something else. So let us talk about their applications, right? So when you say a burstable instance, okay. So a burstable instance, as I've already explained, it is something that performs at an optimal performance to start with. But when you require it to burst out of its optimal performance, it can do that for you as well. EBS optimized. Now these are applications that are used for optimal performance. Now in this case, let's talk about messaging system, right? Suppose you want to deliver messages to people in larger volumes, but at a consistent rate. So you know that the rate is consistent. You need good performance, constant performance, but in lower volume will also work for you. So that is called as your EBS optimized instance, or these instances are used in those places. Dedicated, we've already discussed that they are meant for a specific application. Let's assume that I have highly secure data that I want to preserve and want to work on it in private, right? So I can have dedicated resources which are not shared by anyone, and I'm getting the access to those resources for the time duration I want to access them. Cluster networking. Now, cluster networking is something that basically classifies your instances on a particular cluster performance. Say, for example, I need a particular set of performance in a particular cluster of applications. So I'll be using that kind of an instance there. Say, for example, I might have an instance for backend operations and one for front-end operations. And both the instances are clustered, or all the resources that are there in that cluster, they work similarly, okay, or for a similar cause. So that is what your cluster network instances are. So this was about the theory of compute instances. Let us quickly go ahead and log into our console, and let's see how do these instances work. Okay, so I'm going to quickly go ahead and fire up my AWS management console again. It will ask me to sign in again. That is the standard procedure it has. Each time you sign off for a while, it will ask you to log in again. So there you go, guys. This is my console. So we've discussed this console a little. Let's just go ahead and talk about EC2 instances. Now you can see there's an instance that is up and running already. I do not need this instance. I'm going to terminate it quickly. So guys, when you terminate an instance, it is not available for you to use any further. If you stop it, the instance will be there, but it would be in a stop state. It won't be functioning. You won't be charged for this instance. Okay. But if you terminate it, it would be deleted permanently. So when you talk about AWS EC2, basically, as I've already mentioned, you can launch instances here. You can launch virtual machines here, right? So what we are going to do is we're going to go ahead and launch a virtual machine and understand it from a perspective where we get to know almost all the things about it. Okay. So let's just quickly go ahead and do that. So again, I'm going to come back to the running part. It is shutting down this instance. So meanwhile, just go ahead and launch one more instance. And once we launch that instance, I'll be talking about other pointers as well. Okay. Do not worry about that. So let's just go ahead and say launch. So guys, when you try to launch an instance, you get quite a few options here. So when I say options, there are options to choose from type of virtual machine that you want to launch. So what you see on the top of the screen is it says choose an Amazon image, right? Amazon machine image. So that means you're given a choice to pick a particular Amazon machine. So your instance of virtual machine is nothing but a machine, right? So when it says choose an image, that means image is nothing but, or AMI is nothing but, it is a template instance or a virtual machine that AWS has created, which has some configured or pre-configured values with it. Okay. So you can actually go ahead and launch that particular instance or that AMI, and it will have a set of values or principles or resources attached to it. You can actually go ahead and also create your custom AMIs, but that is a complex process. Let's not do that. What you can also do is once you create an AMI, you can take you can make a copy of it and save it with you, so that actually when you actually want to go ahead and launch a similar instance, you can do that as well. Okay. So this was about the instances in general, AMIs in general. Let's just go ahead and launch one of these instances and see how it works. Okay. So if I scroll down, you can see that there are types here. I have Linux instances, right? I have my Red Hat instance, SUSE. I have Ubuntu. It says that you can actually try out Lambda as well. Lambda, as we've discussed, is a serverless computing service that AWS has to offer to you. You can launch your Microsoft server instance as well. So guys, what you note here is, see, it's written free tier eligible below it, right? So these are the instances that are available to you free of cost. You are not supposed to pay for them even if you release or launch these instances. Not all these instances are free of cost. If you scroll down, you see these deep learning AMIs. Now these are something that are not free for you. Why? Because actually these are something that come with higher configuration, and that is why you're charged for these instances. So the minimal size of instance is something that you can launch under your free tier account that you have. Okay. So this again is a free tier instance you see here. Okay. So, okay, you can actually go ahead and launch some of these instances. Let me quickly just go ahead and launch. Which instance should I launch? Let's launch the Windows one. It is the easiest one to actually go ahead and configure. Okay. So, there are different ways in which you connect to these instances. Say, for example, your Windows instance can be connected through remote desktop processing. But if you have a Linux instance or a Ubuntu instance, for that, you have to actually go through PuttyGen. And Putty, that is something that lets you decrypt your keys, and then you can log into those instances using Putty generator. Okay, it's called as Putty if I'm not sure the exact pronunciation whether it's Putty or Putty, but I call it Putty. Somebody recently corrected me telling me that it is Putty, so let's stick to it being Putty. Okay, let's just go ahead and now launch this instance for now. So I say next. It gives you details about the VPC here, virtual private cloud. It is a networking service that you have in your hand. So you can decide what kind of subnet do you want it to fall under. Okay. So it will give you all the details here for that. You can actually go ahead and change that. IAM role is a security service, IAM, that lets you create IAM roles, who gets to access what. So you can create a new one, or you can use something that you already have if you want one. If I don't do anything, it creates one role by default for me. So I do not have to do anything. I'm just going to go ahead and say next for now. So when it creates something by default for you, it comes with basic settings and security. If you want to optimize on it, you can do that. Now this is where the storage part comes in. Okay. So when you say a storage part, okay, so by default it comes with 30 GB of storage attached to it. Okay, so I can actually go ahead and attach more storage, or I can just change the storage value here. I can go up to 100 GB if I want. So we're gonna see how to actually go ahead and attach volume to an instance, but we'll do that in the later half of the session. Let's not do that now. Okay, so and these are the types of volumes that are attached. That is a general purpose SSD, provisioned IOPS SSD, magnetic standard, right? So these are SSDs. You can also have SDDs, but you don't see that here in option, right? Because SDDs are nothing but a hard disk drives, something that you attach externally. So if I add more volume to it, right, this is where I'll get more options here, right? See, cold SDD, throughput SDD, right? So this is the option that you get when you attach something or volume externally. So the volume thing, we'll get into the details of it later. Let's just go ahead and say now add tags. Tags are something that let you differentiate your instances, because when you launch like 50, 60 instances, it is difficult to classify all those instances. So tagging is a good habit. Security. Now by default, see, I'm gonna RDP sign into this instance. It will use TCP protocol, this port range, and source from any traffic. It will let me get the traffic in. I can choose what IP I want to use as well if I want to. So depending upon what kind of security you want, you can make changes here, right? So if I use the basic one, it says rules with source so and so to access the instance. We recommend setting up security group rules to allow access for known IP only. It says that change it to your personal IP because that would make it more secure. But this is a demo instance. We do not have to worry about it. So let's just say launch. It is again giving me a notice saying that you can improve the security, but let's skip that. So this is the last bit of it, which again is important if you ask me. So when you talk about these instances, right? So basically what AWS does is it lets you sign into these instances through different media, different ways. So what are those different ways and different mediums through which you can sign into an instance? So not different ways. Basically, I misspell or misuse the words there. So basically, when you talk about a key pair here, what AWS does is in these EC2 instances, it actually lets you sign in with a key pair. So key pair is nothing but a collection of public and a private key, as you see on the screen. So what this does is you basically are given a private key and AWS has a public key. Together, they allow you to connect to an instance. You cannot do it without one or the other. Okay. So when you actually go ahead and choose a private key here, it gets downloaded and you have to ensure you keep it safe with you. Because if a private key is lost, you cannot access your instance going ahead. So that is an important criterion there. So make sure you have your private key safe with you. Okay. So how do you do that? You just come here and say create new. Let's call it demo 321. And I say download. So as I've mentioned, keep it safe with you whenever you use it. And now I'm going to just go ahead and say launch my instance. So launching this instance will take a couple of minutes. Okay. So let that instance get launched and then we'll see how the instance works and what else can we do with that particular instance. Okay. So what shall we do now? Okay. So let's just go ahead and take a look at some other pointers meanwhile this instance gets launched. Okay. So if I click on EC2, it will show that one instance is running. Why is that? Because I've deleted or terminated one of the instances, as you can see here. So it does not show me two instances up and running, right? If I scroll down here, you see that I have these spot requests, the pricing that we talked about, right? Reserved instances, saving plans, dedicated hosts, scheduled instances, and all those things. Images, AMIs, you have it here. You can choose different AMIs, right? You can create your own as well. Volumes. Now, if I come to volumes, there is one volume that is already here with me. I can actually go ahead and create other volumes as well. Let's say I want to create one more volume of 30 GB. Let's call it 50 GB just to be safe. I can choose a region where I want that volume to be in. So preferably keep it in the same region where your instance is, and then you just say create volume. And just like that, your volume would be created here. We don't see any right now because it will take time. There you go, your volume is here, right? Its performance is also different. So you can always have a volume that is up and ready with you. So if I click on this, it will give me an option of modifying my volume. I can increase its size. If I have an attached volume, I can increase its size, right? If I actually have to delete a volume, I can do that. I can detach a volume from an existing instance and attach a new volume to it as well. So these are the options that I get with an instance that I create, okay, or volume that I create. For now, let's just go ahead and delete it. I can take a snapshot of it as well. So I can create an image of my volume as well so that I can reuse it, repurpose it. Let's just delete it for now. We do not need it. Okay, so it will delete the volume of the instance. So let that happen at its piece, okay. Let's just meanwhile go ahead and see if our instance is up and running so that we can start using that instance. There you go, our instance is up and running. Its status check is still showing initializing. So basically it goes through 2 status checks for you. You can actually go ahead and wait for it to happen. You can even launch instance right away, but let that status check actually go ahead. If I click on this instance and if I scroll down, you'll get more information about the instance, right? What family it belongs to, which region is it located in, availability zone, as you can see, scheduled events, its type, okay, root device, this is the root volume. So when you actually go ahead and detach a volume and attach a new one, you have to ensure that you attach it to this device or this root device only then that you can attach a different volume to it. So these are some of the things that happen when you, these are some of the things that are there. Status checks, if you come here, yeah, it will give you status check status. So one of the status checks is already passed. See, now both of them are passed. Instance reachability check passed and this also passed. So there you go, we have cleared our status checks rather. So let's just go ahead and launch our instance, shall we? So I say connect, it would say download RDP. Using this, I'm going to connect to my instance, okay? And for that, I would be needing my public private key, right? Private key that I have, but I need to decrypt it first. So I'll have to choose my file. So if I just go to downloads and if I look for demo, I should be having demo 321. This was the one we used. There you go. And now I will say decrypt the key. So no sooner I say decrypt the key, it will actually go ahead and generate a password for me. So I just copy it from here. There you go. I close it. I launch my RDP. It will say connect to the instance. Now what do? We enter the password that we've used. Let's say okay. And I say yes. So just like that, we've actually gone ahead and launched a virtual machine with a lot of ease. Now this is a Windows virtual machine, so it would look like most of the Windows systems that you use, right? So you'd be having similar tabs, similar ability to connect to internet and stuff like that. So yeah, there you go. It is just like the normal instance that we have, right? And here are some links that you can visit to. So you can actually go ahead and connect to internet as well. Whatever internet that you use at home, it is accessible, or you can access that internet using this instance. Again, this acts as a separate machine altogether. See, so I can launch multiple instances in my system. If I click on this thing, it will, okay, let's go here. Okay, and let's take a look at the volume that we have. So we have this 30 GB of volume, 16 GB of it is used for obvious purposes. C consumes that, right, for the software that is installed. And 29.9% was the total 30 GB that we actually assigned to it, right? Can we change the volume here? Yes, definitely we can change the volume. Let's see how to do that. Okay, for that I'm going to terminate this machine for now. Let's say yes. And what do I need to do? I need to stop this instance to do that. Okay, so we will just say stop the instance. Yes, stop. There you go. So it will take half a minute to stop. So I've actually gone ahead and I have a volume that is attached to it, right? So let's just go ahead and do one thing. Let's just go ahead and change its size, okay, and see how does it reflect. For that, we'll be needing a command called as this is the command that we need. Okay, so this is something that lets us connect to our instance, basically not connect, but lets us manage our disk space, disk mgmt msc. Okay, so I'll show you why that is used. We'll get into the details of it as well, but our instance is stopped meanwhile. So let's just go ahead and quickly go into volumes first. Volumes, and in volumes I have 30 GB of volume. Let's just say modify volume and say make it 100 GB. There you go, and I say modify. Are you sure? It may take some time for performance changes to take full effect. You need to extend OS file system or the volume to okay. So it's just like our hard drive, guys. I'll brief you on that, what they mentioned by the commands that are there. So let's just go back to the instance, and whatever change that you've implemented, they say that it might take a while for that to reflect. Okay, so let's just go ahead and see what we can do with it. I'll say start my instance. So it will take half a minute again to start the instance. So let this instance start. Okay, so there you go. So it will initialize my instance again. Okay. So I hope I've launched the right instance. Yep. So the other one is terminated. So this should not be a problem. Once this is up and running and it is initialized, we can actually go ahead and connect our or make the changes to our volume that we have, right? So I was telling you about this command, right? So basically when you say disk mgmt msc, okay, so what this command does is this lets you manage your disk space. Okay, so once we actually go ahead and connect to our instance, let's see if we can connect to it. Whenever you restart an instance, it actually takes time for you to go ahead and connect to that instance. So let's see if we can do it like right away. When I say decrypt, I say copy. You do not have to go ahead and launch RDP each time, okay? I mean download it each time. You can use the one that is already there with you. So let's see if it connects, because normally when you detach a volume and attach it again, it is then that it takes time. But now in this case, it has successfully launched in. Okay. So okay, so if I just come here again, and if I just click on this icon and I say File Explorer, and if I look at the PC, okay, it still shows 30 GB. There's a reason for it. For that I have to go back again and I will have to go into my run command, run option. Okay, desktop app, disk mgmt .msc. Maybe you can start it from here again. So if I click on here, it will give me certain options, right? Extend volume. So I say next, and I say next, I say finish. So now my volume would change here. Let's just go ahead and see the changed volume. You can, okay, it's still not reflecting. It will reflect, do not worry, we've changed it, right? The reason we had to do this was There you go, 100 GB. So it's just like formatting your disks, right? When you attach a volume to it, you have to format it. So that is what I did when I went into disk mgmt.msc. Okay. So this is how you launch an instance. This is how you actually go ahead and do the things that I did with the instance, right? So this was about EC2 instances. You can actually do a lot of things. There are stuff like public IPs, private IPs, right? You can control quite a few other things as well. We'll discuss that some other time. But as far as EC2 is concerned, I believe you people have understood what EC2 is, right? So let's just go ahead and terminate this instance for now. Okay. So I'm just going to say instance state to terminate. And this will take half a minute for this instance to actually go ahead and terminate. Okay. So when you talk about AWS, again, there are other services as well, right? You have storage services like S3 here, where you can actually go ahead and store your data, right? So this is more of a bucket and object kind of a storage. You can see there are certain buckets that are created here. You can create one. Now each bucket is globally unique, right? It does not show any region here. Why? Because you can because buckets are considered as globally unique. So buckets act as folders, right? Where you actually go ahead and upload some data, which you can do like right away here. Let's say add a file. So I'm going to just go ahead and pick up one of the thumbnails that I have, and I'm going to say upload. Okay. And within a minute, that file would be uploaded here right away. Okay. So this is hot storage. That means you store hot data here. That is something that you need to retrieve or store right away. You have cold or archival storage called as Glacier, where you store the data that you are not going to access frequently. So it comes at a cheaper price. So when you talk about AWS, there are quite a few services that are similar to this, right? And you can do so many things with these services. It's just the matter of coming here and exploring these services. So yeah, we just actually did go back and saw how EC2 works on AWS platform, right? It is a virtual machine service or compute service that AWS has to offer to us. We talked about EC2 instances, right? So let's just go ahead and talk about Elastic Beanstalk as well. Let me see if we can actually go ahead and take a look at a demo. Okay. Okay. So, when you talk about EC2, right? Or when you talk about computation services, I've talked about what platform as a service is, right? What kind of service model it is and what kind of services it has to offer to us, right? So let us just go ahead and try to explore Elastic Beanstalk, which is a platform as a service that AWS offers to us. So for that, I'm going to just go ahead and type Elastic Beanstalk. And it will redirect me to that page. Unfortunately, I don't think I have Git repositories with me. Let's see if we can just launch a sample application for now. Okay. Getting started. It says application information. Let's call it sample demo. Okay. Sample demo looks good. Let D be capital so that we can keep track of it. So guys, this is how the interface looks like. I'll be talking about quite a few things as we move further. Do not worry about that. Platform, let me choose one. Let's say PHP. It will by default take an environment. Okay. And then it says use sample application. You can even upload your own code, but let's just go ahead and upload a sample application, right? So, let me explain you what is happening here. As I've mentioned, when you talk about Elastic Beanstalk, it is a platform as a service. What that means is you can actually go ahead and launch applications on a platform that is already there with you. So as you can see, I'm launching a template application here, right? I've named it sample demo. So it asks me what platform you want to use. See, it's giving me all the options that are here, right? I can choose these platforms. There's so many of them here, right? So a pre-configured platform is given to me, right? So it chooses I can actually go ahead and make changes to the versions as well that I have. Okay. So it gives me all these kinds of freedoms. So that is what platform as a service is, right? When we launched an EC2 instance, what did we see? We saw that we had to configure everything from the scratch there. I had to choose I mean, a particular AMI, right? A virtual machine, a template of it. Then I had to, even though I selected by default options, but I selected a subnet for it, security group. I could even control the access there. So I'm setting up an instance at a root level. Here, a platform is given to me. So this platform is also based on a particular instance, right? So the configuration of the instance and all those things are taken care by my platform or AWS in this case. And it sets up this platform for me with ease and with so many features for me to actually go ahead and use, right? So let's go ahead and launch a sample application and then we can talk about these things a little more. So let's just say launch an application. I hope it does not ask me for my Git account. I do not have one right now. Okay, so it's creating all the environment by default, as you can see, right? So see, it will take few minutes because it will do all this process that you see at 10:58 p.m. right? What it's doing is it's actually going ahead and setting up an Amazon S3 storage bucket. So this is where my data would be stored if I use any, right? First it creates a bucket. We'll talk about S3 buckets. It's a storage service where you can store your data. Going ahead, it would create an environment. Okay. So you can see using Elastic Beanstalk, it has chosen a region for my bucket as well. South. Actually, buckets are globally accessible. We'll discuss that later, but yep, you should know that. But it's based in this region is what it's suggesting. Again, what else is it doing? It's creating an EIP, that is Elastic IP address that is associated with my instance. Okay. So a security group would be created that keeps my resources secure. Okay. So guys, what is happening here is the environment is getting created for me. I'm not required to do any of these activities, right? So let this happen, right? Once this happens, so this would be a basic application. We are not doing anything major here, but let this happen, right? I mean, some demo is better than nothing. So let this application get created. So it might take half a minute. So let that happen. Once that is done, we can actually go ahead and talk about other things as well. Now it says that it's waiting for EC2 instance to launch. So basically it will configure the complete EC2 instance that is required for this application to run. And I do not have to worry about anything here. Okay. So added instance as well to our environment. Now it will actually go ahead and put everything in place for us. So hopefully we can start sooner. Okay. So meanwhile it creates this environment. Is there anything else that we can do, right? So let's quickly just open another console. I do not want to tinker with the console that is open already because I do not like the Elastic Beanstalk interface. Last time I created an application and it took me a while to actually search for it. So that is why. Okay, so successfully launched an environment. Environment health has transitioned from pending to okay. Initialization completed 32 seconds ago and took 2 minutes in total. Okay, so we are almost set and ready to go. So you can see that the process started like 3 minutes ago, right? And within 3 minutes, an environment was created for me. You can even actually go ahead and deploy your application if you want. If I just actually go ahead and click on this link, it would open that PHP website for me, right? The application that it launched. So this application that we've launched is nothing but a documentation that AWS has to offer to us. Okay. And this documentation or this application that is here, it is residing on an EC2 instance. Okay. On a platform that is created by Elastic Beanstalk. Okay. So if I come back here, okay, I even have an option of upload and deploy. So I can actually go ahead and deploy my set of piece or my set of code as well, whatever it is. And the option that you saw when we said create a sample application, I selected a by default application, right? We can actually go ahead and do one thing. We can also, if you select to upload a code there, you can actually go ahead and connect your GitHub repository to it. So once you do that, if you have pieces of code that you've worked on and you want to move into these environments, you can do that as well. So as I explained in the initial concept phase where I talked about platform as a service, I mentioned that you can move your data to a platform or you can create ready to use applications based on the platform that is available to you. The platform setting up process is something that is taken care by your vendor, in this case, AWS and Elastic Beanstalk. So as you can see, our basic application is up and ready and we have an environment with us as well, right? And right from creating your application, you can actually go ahead and deploy it as well. Okay. So these are the options that you get when you actually go ahead and work with Elastic Beanstalk. Okay. Let's just refresh it for now. Okay. I go to applications and let's see if we can delete it. So make sure whatever you create, you always delete those applications, because it says delete the name of the application. Okay. Sample demo. That is why I have names that you always remember, guys, so that you do not have to waste your time doing these things. So sample demo, I select it and I delete it. Delete it because even though these resources are under free tier, it's always advisable that you actually go ahead and delete these applications, so that in future, if you forget any of these and you connect something else to these devices which are chargeable, you do not want that to actually go ahead and terminate or harm your free tier, basically. Okay, so it is under the process of deletion, so it should be deleted. Do not worry about that. We should let go of it and go back to our presentation, right, and talk about other concepts. Okay, so we've actually gone ahead and successfully explored EC2 instances, right, how they work. We've also talked about Elastic Beanstalk, right, how you can actually go ahead and set up an environment with ease. You don't have to set it up. Elastic Beanstalk does that for you. Yes, you are open to make changes to it, but since you're opting for platform as a service, it's better all the configuration part is something that is taken care by your vendor. Okay.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.